So, welcome to the lecture today. It's on the Internet of Things and how we can actually physically use this, more specifically for Gatorloop. So we're going to talk a little bit of specific applications to our project, as well as just the idea in general and how it functions and works, and just really what it is, because the concept can be a little muddled in the mind at times as to how this actually is a thing. So what is IoT? Here is the generic definition. So just think you have a device, it has some sort of embedded system on it. You have some sort of control device that essentially functions as a brain for this device, and it's able to talk to other devices. So that's the big thing here. You have devices that can communicate like people can and share information with one another. You do this through sensors. The sensors, like we have our eyes, like we have our mouth. We can communicate information with other people. We can hear, we can sense, we can feel. Providing that through sensors to devices makes them able to interact like we can with each other and communicate that information. The only thing that's different between us and that is that you need some sort of different mode interface in that formatting between how this device can talk to this device. Kind of like how I talked about in the communication protocols lecture, if you were there for that, how you have to, it's like one device speaks this language, Spanish, and you speak English, you have to have some sort of way to go between that. And a lot of this is wireless. IoT is really big on wireless communications using Wi-Fi, Bluetooth. If you're using Bluetooth, it's more of like a light version. I think it's called Bluetooth Light or something like that. It's made specifically for low energy purposes, BLE. And there's other protocols that you can use, other especially wireless ones that you can do this with, but Wi-Fi is usually the big one because it's just very easy to interface with, which is why things like Alexa and the Google Home ecosystems use Wi-Fi, because you already have Wi-Fi set up in your house. You can connect directly to the internet. And it's all about being connected to the internet, so you can use servers to keep your information, transmit, store between different intelligent units. So we can move on to the next part. So I hope you enjoyed that video. It kind of shows you what it could look like in the future. Well, not necessarily like you being like on. Well, actually kind of though. Because think about how you have your Alexa and you can be like, hello, turn this on, turn that on. Our ability to interact with machines is growing exponentially, and IoT is just taking that to a different level. Like, if you saw the video, all the different devices interacted when he talked to them. And like that's essentially what IoT is trying to do, make it so that you can speak and interact with your devices, and they're able to interact with one another to make the world a better place, where you can save time and energy and money and hopefully live an easier life. Some people disagree with that, but that's kind of where we're heading. So it's important to know. Do you have any questions on anything on that video? It's pretty cool though, right? Yeah. So moving forward, any device, as you saw, can be an IoT device. You're essentially just making a smart device, giving some sort of capacity for your coffee maker or your lights to interact over Wi-Fi or some sort of communication protocol to do various things, maybe dim or turn on or start your coffee. For instance, think about you're going through your day, you wake up and you have some sort of band on your arm. That's an IoT device. And it recognizes that you woke up. It recognizes a change in your pulse or something, some sort of sensor. That sensor transmission is then requested by the coffee maker. So the coffee maker recognizes that you're awake because it's talking to your watch strap. And so your coffee maker turns on and pours you a cup of coffee. And then maybe from there, the coffee maker is like sending out data, and your TV picks that up, and then your TV turns on to the news station, and everything is just interconnected like that. That's a very simple way actually to look at it, because that's just one thing happens, causes the next thing. All the devices are always sending out data to where the other ones can pick it up. But it can be a lot more complex than that. It can be, you can really implement a lot of machine learning and artificial intelligence into this process, to where you have a device that's able to make intelligent decisions based off all the information it's gathering. Like, imagine what your refrigerator could do if it was getting information from your car and from your walking habits, from your recent eating habits. Maybe it collects data on like what food you're ingesting. You have some sort of sensor in yourself. Maybe it's measuring your brain waves from some sort of brain interface device. And it gets all this data and it's able to make intelligent decisions on what you should buy from the grocery store. And it can have a display, like a virtual list on the front of your refrigerator that has a list of suggested items. And then you could say, you could speak to your refrigerator and say, hey, I like this suggested list. Take off apples and order this from Publix. And then it would order from Publix. It would communicate with the IoT devices at Publix. And you would have an automated drone, who knows, bring that groceries to your house. And then you could have some sort of device that recognizes that it's incoming and compares a basket or like a cooler on the outside of your house to put all the groceries into. Think about how that could change the way that we interact with things. So that doesn't really show how it's going to be in Gatorloop, but that gives you an idea of what this technology can do and what it is. And we're going to go more into the components. There's really 4 main parts of what makes an IoT system, and we're going to look at each one of those in more detail. So next slide. So yes, how is it applicable to us? So let's try to think about this in terms of a hyperloop system. So for the project that we're going to do as a team, as Gatorloop, we're more centered, for this project at least, on how a hyperloop system as a whole will work, not specifically one unit by itself. Sure, there's going to be applications that will be special to us with our one pod, but there will also be much more applications when you have many pod vehicles going through a tunnel system. So the biggest way that that's important, if you could think of it, is if, let's say, for instance, you have 5 or 6 of these pods that are traveling on the same track. One of them breaks down. It has devices that send out information via sensors to the other ones to indicate that it's stopped. So they can then, machine learning-wise, make a decision of what to do in that scenario. So the pod, one is going this way, it stops, there's one coming directly behind it. It recognizes that, and it decides to make a turn through another tunnel system to avoid that so that there's no collisions. So it just makes them able to make their own intelligent decisions, kind of like how people can communicate. Almost like they have their own phones and they're like, hey, I'm stuck here. Can you do something? Without any human interaction at all. But human interaction is still important. That's something you can't forget with Internet of Things. Without the human interaction, then you just have a system that's running on its own, and if any problems come up, then you're not able to do anything, and then that's a failure. Because if you can't change your own thermostat temperature, then that's a failure. You got to be able to interface with it some way, so you, the user, can make your own decisions based off what you want. Because as much as machines will learn and continue to learn what's best for us, we know what's best for us more than anyone. You would think. Maybe that won't be so in the future, but that's kind of a scary thought, so we won't worry about that for now. So let's break it down. So these are the 4 components of IoT that I was mentioning. Sensors and devices, connectivity, data processing, and user interface. We're going to look at each one of these relative to an example system where we have a Raspberry Pi. So first, sensors and devices. Next slide. So here's a Raspberry Pi, and this has a sensor package that is essentially a backpack on top of it. So if you know anything about Raspberry Pis, they have a bunch of pins along here and along here, and this essentially sits on top like a hat. This is called the Raspberry Pi sensor hat, actually, which is a very simple interface. If you choose to get a Raspberry Pi for yourself, then a lot of the code that I have that's written specifically for this is very easy to implement, and I'll also have that online so that you can try to do some of the things that I have with the code here. So on top of that, remember, you can interface sensors in many different ways. This is just simple because it's very well interfaced with the Raspberry Pi system, and there's a lot of code already pre-written for this and a lot of functions pre-written, so that it's very easy to use. But you could write the code to connect different kind of sensors from these pins instead of using this on top, from the places where this connects, you can connect other sort of temperature sensors or whatnot. The purpose for this, and the example we're looking at, will be to collect like temperature, humidity, and other weather data. So essentially, an intelligent weather monitoring tool that can interface with us and give us information. So connectivity, this is the next big one. So we're not going to get much into what this means. This just kind of gives you an idea of the fact that we're using the internet and how important internet protocol, using IP addresses, having different devices that have recognizable places forced them to communicate with servers over the internet is a big part of what we're doing. So see here, sensors are essentially connected to the cloud through different mediums. So internet protocol is the big medium we're using, and overall you want to connect to some sort of server, some place where information is physically stored somewhere in the United States. There's a lot of those. If you don't know much about the way networks work, essentially you have an internet service provider, perhaps Verizon, someone else, and they give you access to these servers and to the network through you sending a request using the internet protocol. So you have your information, you want to get something, you want to access some sort of website. Essentially, this is a general rundown. You're like, okay, I want to get this. You send that request across the network, it goes to your internet service provider, and then they pretty much see, okay, do they have Verizon, do they not? And if you do, then you're pretty much just let through, kind of like a gate. You can think of it like a gate. There's even a gateway address. Yeah. But essentially, they let you through, and then you're able to connect to those servers that they have access to and control of. So that's, and this also speaks that there's many different ways for that communication, for that that gate to happen, essentially, using Bluetooth or Wi-Fi to bridge that gap. So, here. So data processing. So this is third, and perhaps the most important aspect besides the physical connection between the devices. It's actually making that data into something usable. So when we have this data on our server or in our code base, we need to be able to make it into something usable, because a lot of times the readings from sensors are pretty unintelligible. You get random numbers like 1, 5, blah, 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 bunch of decimal points, and you're like, well, this doesn't make any sense to me. So you have to process that into something that's usable and readable and that would make sense to you. Because if you're just putting the raw data from your device and like sending it via like a push notification to your phone, and you get like a bunch of garbage numbers, you're going to be like, what does this mean? Or maybe you just happen to know, but the general user is not going to know what that means. So they'll be like, what does 17392 mean for my temperature of my house? It won't make any sense. So you need to be able to write some software that can handle that. And a lot of times it's not that complicated. There's a lot of libraries, especially in the Raspberry Pi, to handle a lot of this data processing and manipulation of it into a form you need. So that's not a big thing you need to worry about unless you're using a device that doesn't have as much libraries written for it. Like a lot of Texas Instruments microprocessors don't have, a lot of them do have a lot of support. But as an example, if you're using something that's like really cheap, then you're probably going to have to do a lot of the like hard upfront work yourself. But of course, there's that trade-off. You get a cheaper device, you have to write more code. You don't have that library support. But also, when you're writing your own code, you can make it even better. You can have it be more efficient and do exactly what you want, which is how you make a lot of money. That's what the people at companies want, ultimately. The people that can do it all themselves and make it better so that the company can get the most profit, essentially. Make it be the most efficient. So I think that kind of covers what I also included here. It can be simple, checking your temperature readings, or it can be something like processing visual data from some sort of camera sensor that takes a 3D model of this room, for instance, and is able to recognize where people are. That's, of course, a lot more complicated. You need to know a lot more stuff. Like, I don't know how to do that. I can do the first one. But the second one includes a lot of like machine learning concepts, stuff that still yet to be learned. We won't have to dive that deep into what we're doing. Meaning, you got to do something or they're going to explode. I think that's a very useful way we can use that. the user interface. So I mentioned this a little bit before, but without a good user interface, you have no way to interact with the system, and you're kind of excluded from it. You don't want to be left out on that. Like I said, you don't want to change the temperature of your house and then it not let you. So usually for something like this, you want to be able to, like, at least in the future, say, hey, set the temperature to this with your voice, and it recognizes that and does something with that. Or an app on your phone. You can change the temperature with your phone from wherever you are, so you don't have to be there, or both. Or have an actual physical thermostat where you can change the temperature. Depending on what you want, the user's preferences, you just need some way to actually interact with it so you can get things how you desire, not just how the system desires. So here is an example of a user interface. Someone could, on our GUI team, write a graphical user interface like this. So it's really cool to see how that side interacts with the Internet of Things side. So, for instance, living room temperature. You can adjust your finger along the dial, change the temperature. You have a way, other than it just setting it on its own, to choose what you want to happen, which is just very crucial. You need to have some sort of control system in an IoT system, or else you're left out. We don't want that. So that's it for these slides. So now I'm going to go over some code and explain the concept more of how this is actually going to work, more than just the concept side, the actual application, how we can do this. So pause it. Cool. I'm just going to more sit here, point, highlight things. All right. So you can start it.
Yeah.
So this is general code written for the Raspberry Pi interface with that sensor hat / backpack that I talked about earlier that pretty much is attached directly to the Raspberry Pi. Which is why there's this variable sense that's equal to sense hat. This is part of the libraries that are predefined for the Raspberry Pi hat, which has temperature, humidity, and pressure sensing. So remember, the purpose of this code is to collect the data on just your general climate and continuously send that back to you so that you have it. So in the end, what this is going to do is create a log that is putting data every, I believe, 4 seconds into a text file. And in that text file, it's just going to keep storing it over and over again. So we're going to need memory to store all that data in that text file on the device. There's something to keep in mind there. We're also going to, in the end, send a push notification to your phone where every so often it will again and again prompt you and tell you what the current temperature is. We're also going to see how it works with an email, how if you want to send an email every so often to yourself. I believe the way I have it set up here, it's sending an email every couple seconds. You obviously wouldn't want to do that in a real application. You probably don't want to get an email every couple seconds. You probably want it every day, if you're being reasonable. Like if we had this, let's say you have 2 houses and you have a house on an island and you want to keep checking on the temperature there. You would want it to send maybe once a week, right? So you can have it set up so you get an email once a week about how everything is doing, how the temperature is and all that. While that data is also being used for other applications and is communicating with other devices to make other decisions. You're also getting that feedback from it. So remember, there's just multiple ways that you can manipulate the system and that you can use it. Before I get more into what this loop here is doing, I wanted to mention that to use this code first, you would need to put an operating system onto your Raspberry Pi. That, I'm not going to go over that because that is pretty simple to do. All you really need is, let me see if I can find it, an SD card formatter. You essentially just put your SD card into your computer. You run this formatter. I recommend using a 32 gigabyte SD card because you want something large for your operating system to work on, because operating systems take a lot of space and you need a lot of memory because you're essentially making your Raspberry Pi into a computer. So think about how many gigabytes of memory your computer has. So you want at least a 32 gig card. If not, if you needed it to be small, a 16 gig card is going to work, but I would go with the 32. That's the recommendation. So essentially format your SD card, and then there's something called can pull it up real quick. Raspberry Pi News, which is the actual operating system, just so you can see it. I'm not going to start the download, but you just need to look it up, and it'll essentially put everything into a zip file. Yeah, there it is. So you download it off this website. It's in a zip file. You extract the files from that into your formatted SD card. You're just literally copying, pasting it all in, simple, and then you're able to remove your SD card and put it into the SD card slot on your Raspberry Pi. So then once that's done, you're set, you have an operating system that's up and running, and you're able to, on your Raspberry Pi, run and like set this Python code that you can then use to do the things we were just talking about. Does that make sense? Any questions thus far? Awesome. Well, not awesome yet, didn't have questions, but now we can keep going. So here, if you're wondering what this is, I'm not super familiar with Python. I'm more of a C and C++ guy, but this is essentially what you need to get the necessary library files to work with time on this and to work with the SenseHat interface that we talked about earlier. All the sensors that are connected to the Raspberry Pi. That's already set up in library files. So essentially we have this loop here that will run. There's more to this that is in these programs here. So essentially all this would be in one Python file, but I have it broken up so just so you can see it better. And the way I have this set up right now, this code won't actually run because I just have it essentially in a text file using Sublime Text, just so you guys know. So I have this while loop here, so you're running this code over and over again. We're taking temperature, humidity, and pressure data, and we're setting it, this is just a round function, rounding the number. This is just converting it to Fahrenheit. You're using this function that's predefined called sense to get temperature, get humidity. This should be get pressure, not get humidity, because otherwise our pressure variable will just be getting set to the humidity data. We don't want that. So then you essentially want to store those different readings that you have into new variables. So the purpose for doing this, see, where percent decimal is just your actual data. This is just going to show a t, like when we're actually displaying this data, it'll show t is equal to your number and then f next to it for Fahrenheit. So pretty simple there. This message is it's used for our notifications and for the email, but I'm not going to show the implementation here, but on the hat that we're talking about, the sensor hat, it has an LED matrix on it where you can display like actual values on it. Like if you've taken digital logic, if you remember your display, it's similar to that in the way that that works, except your values are scrolling across it rather than just like appearing and changing. Because if you have multiple things and it doesn't fit into your matrix display, then it'll just scroll. It's 8 by 8, that is important to know. So essentially you can see your data scrolling across by making this message. But as of now, that's not happening yet because we just have this message variable that stores this. So we need to actually display it. So if we're working with that sensor display screen, and the reason I'm doing this in multiple places is just to, like how I mentioned, we're doing the notifications, the email. This is talking about displaying it on the sensor itself. This is just so you can see that in IoT there's many different ways to do things, and we want to have data available to us in many different forms. Like you want a text file for different purposes. You want to be able to check your records and know what time things are at. You want to be notified on your phone so you know if there's an issue. Like, oh no, my house is 100 Fahrenheit. There's a problem with the temperature. It's just so you know what's going on. And you're using information in different ways. So you need to know the multiple ways you can have that. So this line of code is specific to the hat, the sensor hat, and how it works. You set a speed for the scroll. You can set your specific text color that you want, and you can set a background color. So just so you know, this function sense, show message. This is all inherent to the code that's already there. So this isn't a function you have to make. It's already available to you through the Python libraries. This is just setting a delay because if this just delays it 4 seconds. Because if you're not making a delay between things. For instance, on your sensor hat, it's going to be scrolling you're just going to have tons of data constantly updating, and you won't have time to display that. Or if we're talking about the text file where your data is going to be stored, it's going to fill up memory mega fast. Because if you're doing it like every millisecond, think about how much memory, like if you have 32 gigabytes of memory, that's going to fill up in a matter of like maybe a minute, which would be bad if you're trying to have this device last for years, right? So these are things to consider, which is why we probably want to like make it a day between measurements. Like we're dealing with we're trying to get climate readings. We only want that data once a day, or maybe measure it a couple times a day to get the average. And then on that data processing side I mentioned, you would want to compute that average and display it back to the user and have that data saved. So see how you're starting to see how it all interconnects there. So this code right here is specific to creating that text log. So all you really have to do is make your own text file. For instance, this one would be called weather.txt. This opens that and sets it equal to this variable log. And then this deals with the time here. This is part of that time imported library that we were talking about. I'm not going to get too much into that. And then this is just another function that's inherent to the text file library, log.write. So now you're writing this message, the message variable we had up here, which is taking all of the different data, the temperature, humidity, and pressure, and putting it into that file. And then it prints it onto it. Pretty cool, right? And then you need to close that log after all the file is still open. So we're essentially opening a file, we're putting the data in, and then we're closing it. And then we're sleeping for a certain time, that delay. We're waiting a little bit before we get back and start this again. Because something important to know, sometimes if you don't have long enough delays between things that happen on your microprocessor, on your computer device, then you can run into other problems because some processes might not be finished yet. Like let's say for a certain application, something you're doing, you have to count from 1 to 100 milliseconds for all of these calculations to be done. But if you don't have a long enough delay before you start doing other things with that data, those calculations won't be done, so things are going to fail. So just something to keep in mind. You have issues that come up like that in some of the projects you do in microprocessor applications, just to relate it back to other things. So let's look at this email and how that's working. So you have it. This would also be like technically in this. I just, like I mentioned before, have it broken up so that you can see a lot of this more. So these would just be some of the other import things that you would have also here with these. This is everything that's needed specifically relating to the timing of your emails and using this email text system. So MIME, multi-part. Purpose of this is to make it so that you can break up the different parts of what an email is and address them specifically, which you can see here. That you're setting a from address, a to address, and you're actually able to put a subject in. So the reason we're able to do this is because we're using this MIME multi-part email addresser. You need some sort of variable to hold the address that is coming from, and two, remember that email addresses are essentially just IP addresses, just with labels given to them, which is kind of cool to think about, because it's just like a string of numbers, like an IP address, like your computer has, like your phone has, except it has some name given to it so that it's easier for us to work with, which really amazed me when I found that out, because I was like, whoa, I've been typing in these web addresses, and they're literally just like a bunch of numbers that are routing me to a specific memory location where all this stuff is stored somewhere in the world, which is pretty crazy when you think that like someone designed this whole system and made it so that you can give these things labels. I just think it's pretty cool. But anyways, this is just a test email account that you would have and another test like Python email account. So this would be on your Raspberry Pi. So it's sending to your device from whatever test email you have. So you set that from address equal to the from in your message. Remember, message is this function, the MIME multi-part function, where it's recognizing, oh, I need to find from in the email, I need to find a to, I need to find a subject, and this is what I'm putting there. So it's putting this email address to the from, this to address to the to, and the subject to the subject. Is there any questions on how that's happening? Cool. So then essentially right here I just said then do what the other code does, which is like all of this. So this is all happening before that starts. Sorry. This, all the stuff we just talked about, happens before that other code runs. And then after that, we're dealing with like the actual message. So there's another, so that we're using that message function again, which remember is just another name for this MyMe multipart. So we don't have to write MyMe multipart again and again and again. So remember, attach is just a function technically of this. We're just giving it a different name. Like kind of how these emails are just another name for all the numbers that they represent. Just making it simpler for us to use. So message.attach, we're taking that our message variable from before. If you remember, we made it over here. Where was it? This message. This is what message was. The actual data where it's going to say t is equal to a number with an f after it, h is equal to that, and this, and it's going to be displayed with commas. That's what it's taking, and that's what your email would say. So your email would actually have, it would literally just say, I'm going to put it down at the bottom here, t is equal to whatever numbers. That's definitely not what it would look like, but it wouldn't be that number. And then like your temperature or pressure, whatever, blah, 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 and humidity, blah, blah, blah. Like that's going to be the text of your actual email that you're going to receive. If you're running this code. Just to give you guys an idea. It's taking that message, that's what's going into it. Plain is just something you have to put. There's other options you can use for this, but for our purposes, that's what you need to know. So then we are calling this function here, server. So there's a lot of functions that are part of server, are a part of this, but we're calling it server again to make it more simple to use instead of using this whole name. This is using something that's already predefined to help us. So don't really worry about this. If you're interested in how this is working or what this is, you can look more into that more. So there's a function that's made to start your server. Just start TLS. You run that, your server will begin, and then you have to log in. Essentially logging into your email, just like you would. You have some sort of password that you create. It like actually logs into your email because you can't send and receive emails unless you're logged in, right? So this program needs to be able to do that. So this would be whatever your password is. I don't know, whatever name you want to make. It's taking that from address variable that we made earlier and logging in, which is really cool. And it's taking, remember the message function that we made, that was another name for this MyMe multipart. It's making it a string, because if it's not a string, you might have errors when it's put into the email, because it might interpret it in an incorrect way. So remember, string is just like a sentence, like that we would think of a sentence, like actual text, versus weird, different definitions of numbers. So don't think too much into that, but something we need to have. So then we're using the server function again. We're actually sending the email. We're using the from address, the to address, and that text that we had predefined, which is now our message converted to a string. So we've taken that initial message that has the values, we've made it a string, and these three things are just parameters of this function that it takes to send the email. So it's this function someone else made, it's part of the library. It's just set up to take your from address or to address and the message and send it. We already set up everything else. It knows everything it needs to know, so it's able to actually send that email. And then you quit the server. On how we initially started it, we did what we needed to do, and then we got out of it. So now this email is going to happen, and then we're going to sleep. We're going to close our log, and we're going to sleep. So at the time, it was also recording all the information in a log. So we're doing a lot of different things here.
So
yes?
So is all of that stuff in the email also in the while loop?
No, that's after, actually, sorry, yes, it would be. This would be included in the while loop so that we can continuously do that, including our delays, so that it's not all happening super quickly all at once. So here is the last important part. So this deals more with formatting of things.
It's running right now.
JSON is JavaScript. I don't remember what ON is, but it's essentially just file formatting protocol where we're able to make it so that our file is in the correct way. If you don't know what an API is, I'm probably going to mention it several times here. It's an application programming interface, which is essentially, you can kind of think of it like library files. It's not the same thing, but just think of it as something that's provided to make the user programming experience easier. Like Java has an API where they provide a bunch of functions, like their string function and all that stuff, that makes it easier for you to do your stuff. Because remember, without predefined functions, you would have to make it all yourself. And remember, all programming languages are based off of assembly language, and assembly language is based off of your, like, literally binary numbers put into a computer. So API is just a new interface that you're given to make it easier for you to do your software development. You can kind of think of it like a level of abstraction. That's a good way to think about it. So to do what we need to do, we need this hyperloop, we need JSON. And then we also need to deal with our string input output. These are just things that we're going to need. I'm not going to talk about them too much. Remember, this would also be like in our overall file. It's just broken up so that we can do things. So we need to clear our sensor before we're doing things over here. That would be like right here. I'm starting to see that breaking it up can make things a little confusing, but I hope that it's not super confusing. So these numbers are reset so that we have, this is like for the push notification, by the way, so you guys know. That's what this is all about. You can actually do this through an app called InstaPush, which you can download onto your phone, which is something you guys can do and I recommend doing. So you can like, try to use this with the Raspberry Pi. Anyways, back to this. I set these two variables, cold and hot, so that we can have a specific value for when you're actually going to get the push notification. Like if your room is too cold, it'll send a notification. If it's too hot, it'll send a notification. So you can know and know what to do in case something, in case you have an issue. And this is just setting up our actual push message to actually work. So remember how I mentioned LED matrix. This is where if you were going to display it on it, you would do so. I didn't include that here, so I don't want to talk about matrices today. I have to deal with them enough in linear controls. Anyways, here's the three main things that you need to use to InstaPush. You need some sort of app ID, app secret, and push event. You can really just think about the app ID as like your username, the app secret as your password, and then the push event as like the actual event of that push notification occurring. So there is something called, if you don't know about it, the event system that's used on a lot of microprocessors, which basically, just think of it, if you know what an interrupt is, it kind of works in a similar way. It's not the same thing, but just to give you an idea. Another way to think about it is just, you need something to happen, and while you're doing your other stuff, it'll handle that, and it'll do that. So it's a pre-made, hardware-made like communication within your device to have these channels where you can do different things while you're running the rest of your stuff. So like, you're dealing with all your stuff over here on the left, and on the right, at some time it's triggered, the event is triggered, so it handles it while you're doing your stuff. It's kind of like a little helper. You can kind of think of it like that. So, I don't want to talk about what curls are, so we're not going to talk about that, but you need some sort of variable that you're using this Python curl function with. So you can actually post to the InstaPush API, so you can actually like, deal with it in InstaPush. And so I think it would be helpful if I pull up InstaPush so you guys can see that. I think I can pull it up on here, not on my phone. This is more like a phone app. This is not the same one. That's for Instagram. I guess I can't for automation. There we go. Yes, not Instagram. Yeah, I think this is the app, but you have it on your phone, and there's a place for you to put in, like, it shows you the app secret and the app ID information for your device, so that you have those. It's not like you have to go search somewhere for it. It's like information on the app. It tells you, and you just need to put them in here. Which is usually something you have in a lot of embedded system-related applications, or anything really where you have things communicating. You need a place to take that in immediately, even if like you're not ready to deal with it. So it's kind of like a basket where you can hold stuff before you do other things with it.
So I got liking. I was gonna get close-up shots just
And then
for the
this
promo
you just
video.
show that it was actually sent, and
So I guess it just
with
records
setup,
the lecture.
as
I can
now,
get
I
up close to
can
him.
include it. Here you can have
Lens is really big.
essentially two like loops to where
Like I can't
it's
see that.
or two if statements
Yeah, you can
saying like
take
if
photos
it's
of
this certain
places.
temperature, if it's cold, which was the 37, or if it's hot, which is the 40, then you're going to do the push notification. Pretty simple from that point. And it's just using all this predefined stuff to where you have your simple logic that you're implementing to choose when that push notification is going to come through and occur. And that is pretty much it. And I'll post this code on the Slack so you guys can have access to that and look over it, look into things, understand it on a deeper level. So is there any questions on that?